So we are going to start hydrogen chloride. Okay. Hydrogen chloride is one of the compound, and it is a compound of what? The two things you can already see here, hydrogen and chlorine. So it is a compound of hydrogen and chlorine. Hydrogen chloride is a compound of hydrogen and chlorine. Then the next thing which you have is when you take this hydrogen chloride, then its formula. What is the formula? You know, the hydrogen chloride is HCl. And this hydrogen chloride, hydrogen is a non-metal, chlorine is also a non-metal. So since both of them are non-metal, what will happen? Whatever bonding will they form? You have done bonding, isn't it? So what type of bonding will they form? Anyone?
Covalent.
They are combining with covalent bond, isn't it? So whatever bonding, covalent bond. And you know, in covalent bond, what happens? Sharing of electrons takes place. So hydrogen and chlorine, they share a pair of electron, isn't it? So how do they share? I can give you like this. Hydrogen gives 1 electron, chlorine has 7 electrons, so it also contributes 1 electron. So hydrogen has 2 electrons, that is stable. Chlorine has how many electrons? 8 electrons. So that chlorine is also stable. So compounds of hydrogen and chlorine, that means they are combining with the help of a covalent bond. This is your electron dot diagram. Electron dot diagram. Understood? Now, the next thing, if you take, then in this case, one more thing is there, that is, if the formula is HCl, it will have a mass also. So it will have a molecular mass. Molecular mass. Hydrogen, the mass of hydrogen is 1 and chlorine is 35.5. So total will become how much? 36.5. So its molecular mass is 36.5. Then it will have a vapor density. Vapor density is always half of molecular mass. Remember that. Molecular mass you already know. So half of it is how much? 36.5. You'll divide it by 2. So you'll get 18.25. That is your vapor density. This I'm giving so that when you do the next chapter, it will be easier for you. So molecular mass fixed, vapor density also fixed. Hydrogen chloride, is it a solid, liquid, or a gas? You have heard of hydrogen chloride, isn't it? So hydrogen chloride is a solid, liquid, or a gas?
So gas.
Isn't it? So hydrogen chloride is a colorless gas. Clear? Hydrogen chloride is a colorless gas, but you know HCl, we write for something else also. Recently, I've done acid, base, and salts, isn't it? We wrote HCl there also. So HCl is also used for hydrochloric acid. Now, when you use hydrochloric acid and hydrogen chloride, what is the difference? That also you have to know, isn't it? This hydrogen chloride, which is a colorless gas. Actually, it is highly soluble in water. Hydrogen chloride is highly soluble in water. So I'll write down here. It's a colorless gas which is highly soluble in water. So if I take hydrogen chloride, it easily dissolves in water, isn't it? And since it is dissolving in water easily, what will happen? We'll get a solution. That solution is called hydrogen chloride. Solution in water is called hydrochloric acid. Clear? So here I'll write down an aqueous solution of hydrogen chloride. An aqueous solution of hydrogen chloride is called hydrochloric acid. Is it clear? So it's very simple. When you are taking it in gaseous form, then we'll say it is hydrogen chloride. And if we take it in terms of solution, then we say it is hydrochloric acid. Clear? So whenever we take it in solution, that means when we are talking about acid, base, and salts, we have already dissolved it in water, isn't it? So hydrochloric acid means it is a solution of hydrogen chloride in water. Understood? So this you have to know. Then the next thing, when I take this hydrogen chloride, where do you get? Is it found everywhere? No. In nature, directly you don't get. But there are some places which are very common where you get. Yeah. So if I talk about occurrence, isn't it? Then where do you get it? Normally in nature, you don't get it directly. Clear? In free state, it is found in those volcanic gases coming out from volcanoes. Some amount is hydrogen chloride that is there. The one which you have to know is in your stomach, there is a gastric juice, isn't it? In your stomach, there is a gastric juice. So that gastric juice contains hydrogen chloride, means hydrochloric acid. Clear? Gastric juice in your stomach means mammals and all those things, animals. Many times what happens? These are used for digestion of food. This helps in digestion of food. So it is found there. Apart from this, in combined state, this is in free state. In combined state, if you talk about combined state, it is found as chloride salts. Whatever chloride salts are there, they all are coming from hydrogen chloride or hydrochloric acid. The salts are obtained from this. Clear? So when I take this combined state, if I say sodium chloride, NaCl, that is your common salt, isn't it? KCl, MgCl2, these all are salts of hydrochloric acid. These all are salts of hydrochloric acid. Is it clear? So these things are there. Then if you take this hydrogen chloride, how will you prepare it in lab? So laboratory preparation, LAB laboratory preparation of hydrogen chloride. When I write laboratory preparation of hydrogen chloride, then in that case, what does it mean? We are producing the gas. Hydrogen chloride, I didn't write hydrochloric acid. If I write hydrochloric acid, then it says that we are going to produce the solution. Clear? So laboratory preparation, how do we do? These are the important things which you have to know. This is very important again here. If you talk about hydrochloric acid, how is it prepared in the laboratory? Clear? So for this, what you have to do, you have your book. There's a diagram given there. You'll follow that diagram. Clear? And whatever points I'll write down, those points are very important. You learn in terms of the points of this. Clear? You learn in terms of points. So when we talk about laboratory preparation, we are going to start the preparation with some chemicals. So the chemicals which we use, they are called reagents. So reagents used. Which reagents are we going to use? Okay, so the first one, to prepare this, we use sodium chloride. Sodium chloride. Sodium chloride, the formula is NaCl. You know that. And this sodium chloride has a name also, a common name. What is the common name of this? It is also called common salt. The salt which you use at your home, that is sodium chloride. Yeah. Then we use one more thing, that is concentrated sulfuric acid. Concentrated sulfuric acid. Concentrated sulfuric acid formula is H2SO4, and it is also called oil of vitriol. This is a common name. Common names I'm giving you so that sometimes, somewhere it is given, you should not miss out. Is it clear? So concentrated sulfuric acid. These two things we are going to use it. So sodium chloride, concentrated sulfuric acid, these are the two things which we are going to use. Formulas, you learn it. These two will take it in a round bottom flask, and then we'll heat these two. Clear? A particular reaction will take place. So the next thing which you have to know, remember the first thing was reagent used. The second thing is you have to know the diagram. You can refer to your book. The diagram is given there. So that diagram you have to follow. Clear? You all have your book with you. You can see there, laboratory preparation. You'll see there's a flask. There's a flask in which we take these two things fitted with a Fischl funnel. Through the funnel, we add sulfuric acid, and sodium chloride is already there. Through the delivery tube, what will come out? The gas evolved. So what happens? The diagram, you see it. So when I take this diagram, you see the book. Then the next thing is when I take this, what reaction takes place? A particular reaction will take place, isn't it? So which reaction takes place, that you have to know. So you know, we have started with these two things, means these two are the ones which are going to react. So we'll start with NaCl and add H2SO4. Now this H2SO4 is concentrated. Remember that we cannot use dilute. It has to be concentrated. Clear? So when I use this, then in this case, what will happen? These two will react. We are going to heat it. So when we heat, for the preparation, we heat up to a particular temperature. So the temperature is kept below 200 degrees Celsius. Now, why? I'll tell you just now. But let's complete the reaction first. Below 200 degrees Celsius. Temperature, we can go to higher temperature also, but we always keep it below 200 degrees Celsius. So once this reaction takes place, then what we do? The next thing is your product NaHSO4, sodium hydrogen sulfate with HCl. This gas is given out. Hydrogen chloride gas. Arrow pointing upward means it is a gas. Arrow pointing upward means it is a gas. So sodium chloride with concentrated sulfuric acid, temperature is below 200 degrees Celsius. Sodium hydrogen sulfate. What you can do is, when you are studying, you can always write the names just below it, then it will be much better. I'll just show you this example. This you'll write down. Sodium chloride. Then this you'll write down sulfuric acid. This you'll write down sodium hydrogen sulfate, and this is hydrogen chloride. So this way, when you write, it will be easier for you to learn also. Clear? And you'll know the formulas. You'll be familiar with the formulas also. So always, whenever you're writing, keep on writing the names just below the things. Especially in these cases, wherever you are studying the properties of other things, preparations and all those things, write the names. Clear? And this reaction has to be balanced also. This reaction which I have given you is not yet balanced. Unbalanced reaction is wrong. So this reaction has to be balanced. If you check it, always check it. This is balanced, I think, isn't it? The reaction itself is balanced. Okay. If not, you should always balance the reaction. Understood? So this, you'll do it. After this, what we do, remember, we are heating it. So since we are heating, there'll be moisture and other things also, isn't it? Hydrogen chloride gas is coming out, but there will be moisture and other things which will also evaporate from there. Clear? Water evaporates, water vapor, moisture will be there. So we have to remove all those things. So the next step, once this is done, this gas will come out from the delivery tube. The diagram you'll see. And then when it comes out from the delivery tube, along with this, moisture and other things will also come out. So we have to remove that. So to remove that, we have the next thing, that is drying of HCl gas. How do we dry it? These are the points which you have to know. All underlined points you have to know. Clear? So drying of the gas. This diagram, I told you diagram, you don't have to draw the diagram. Labeling of diagram only comes. Clear? The diagram will be given. They might ask you what is present where. Okay. So drying of HCl gas. How do we dry it? I told you last time also, we have certain substances called hygroscopic substance. They can absorb moisture and their form will also not change, isn't it? They can absorb moisture, their form will not change. So that's why what will happen when you are taking this, then in this case, these are things, we can use a hygroscopic substance which can absorb the moisture. So for that, what we do, You have to choose a certain substance which does not react with HCl gas. Clear? It should not react with HCl. Understood? So in that case, what will happen? We'll choose concentrated sulfuric acid. Clear? HCl is also acidic, sulfuric acid is also acidic, so they both are acidic, so they do not react. Clear? So what will we do? We'll write down HCl gas, means hydrogen chloride gas, is dried by passing through hydrogen chloride gas is dried by passing through concentrated sulfuric acid. Yeah. What happens? Which absorbs all the moisture. So what will happen? All the moisture is absorbed by concentrated sulfuric acid, and what will be left? A dry gas will be left. That means dry hydrogen chloride gas will be coming out. Clear? You'll see in your diagram only there are two containers there. In one we have filled sulfuric acid, and in the other one will collect. So the next step after drying is collection. Collection of hydrogen chloride gas. How do we collect it? This collection depends upon whether the gas is heavier than or lighter than air. Clear? So when I take this HCl gas, the vapor density was 18.25. We have already seen air, the vapor density is 14.4. So you can see HCl is heavier. So what will happen? If I take air and hydrogen chloride, air is lighter, it will move up. Hydrogen chloride will move downwards, isn't it? So what will happen? This hydrogen chloride will move downward, means we pass it through a container, the air moves up. So we call the process upward displacement of air. Air is moving up and the gas moves downward, isn't it? So collection, HCl gas is collected by HCl gas is collected by up displacement of air, is collected by upward displacement of air. So when I take this upward displacement of air, why do we do it? Just now I have told you why do we do? Because there are two reasons. The first one, it is heavier than air, and the second thing is, and also it is highly soluble in water. It is highly soluble in water. Many gases we collect it under water, but this gas is highly soluble in water. That's why we don't collect in water. In water, as it comes in contact with water, it will dissolve only. So we don't use water to collect it. Is it clear? All of you have copied? Any problem? These all points, whatever points I gave you, all these points are very, very important. Okay, now you have done the main things. The main things was what are the reagents used, sodium chloride and hydrogen sulfuric acid. Clear? The diagram, you'll take it from your book. The reaction will be sodium chloride reacts with H2SO4. It forms sodium hydrogen sulfate and HCl, isn't it? The reaction temperature is always kept below 200. That I'll tell you why. Then drying, we always dry it with by passing it through concentrated sulfuric acid. And the next thing was we are collecting it by upward displacement of air. Yeah. Why? Because it is heavier than air. So heavier than air means it will go downward, and it is highly soluble in water. So since it is highly soluble in water, we don't collect it under water. So these points you have to know. Understood? See on your screen. The diagram is given there. This diagram, you have it in your book also, isn't it? Do you have it?
Yes, sir.
Yes, sir.
Okay, so you can see there in the first container, you have sodium chloride. And then what is there? You can see there that sodium chloride is taken in a container. On top, you have a thistle funnel, isn't it? So that thistle funnel, from there, what is going in? Concentrated sulfuric acid. The two things, they react. We have to heat it, they react. Then from there, whatever gas is produced goes to the next container. Next container contains concentrated H2SO4, isn't it? So the gas is passing through concentrated H2SO4. So here what happens? When you take the middle one, the gas is passing through concentrated H2SO4. You can see the bubbles coming out. So what happens there? All the moisture is absorbed by sulfuric acid. And then it passes into the next container. The next container, you can see what is there? The pipe, the delivery tube is pointing downwards. So since it is pointing downward, what will happen? The gas comes out there. Since the gas is heavier, it will move down and the air moves up. You can see the arrow given there. Air is moving upward and the gas is moving downwards, isn't it? So in that case, what happens? This dry hydrogen chloride gas is collected at the bottom and the air moves out. So slowly what will happen? The whole container will be filled with hydrogen chloride gas. Clear? So this is your diagram. You should know about it. Clear? They won't ask you to draw the diagram, but instead of, suppose, sodium chloride, I write A there, B there, at different places, A, B, C is written. You just have to identify what those things are. All the arrows which are given, instead of that, suppose I write A, B, C, D, and then you have to identify what is that A, B, C, D. Clear? So that way your diagram can be given. Understood? So this is how the preparation is done. The details you have already written, isn't it? So let's go back to what we were doing. Now, the next thing is, from all these things, some few points are there, which I'll discuss. So you'll write down for this points to note. These points to note is all about hydrogen chloride only. The preparation of hydrogen chloride, there are few points which you have to know. So what points you have to know? We'll discuss that. Yeah. So here, the very first thing, when we are preparing this, we are choosing sodium chloride as a reactant, isn't it? Why we are choosing sodium chloride? Why not some other chloride? That you have to know. Why we select sodium chloride only, isn't it? So I can write down this. NaCl is preferred as a reactant. One of the reactant is NaCl. So why do we prefer it? Is preferred as a reactant as it is cheap, means cost is very less, isn't it? And easily available. It's cheap and it is easily available. So NaCl preference, now you know it. The second thing, along with NaCl, we also use H2SO4. So instead of H2SO4, can we use other acids? Can we use nitric acid or any other acid? No, we always use concentrated sulfuric acid. So concentrated H2SO4 is used as a reactant, isn't it? Clear? Is used as a reactant as it is a non-volatile acid. It is a non-volatile acid, that's why we use this. Understood? So concentrated sulfuric acid is used as a reactant since it is a non-volatile acid. Clear? Concentrated sulfuric acid is used as a reactant, isn't it? Why we are using it as a reactant? As it is a non-volatile acid. Concentrated sulfuric acid is used as a reactant as it is a non-volatile acid. Non-volatile acid means the acid does not go into vapor state easily. Clear? So it will not vaporize. So what will happen even when you are heating it, the vapors of this acid will not be formed. Whereas if you use other acids, vapors and other things may be formed. That means along with HCl, you may be getting some other gases. Clear? So H3SO4 being a non-volatile acid, it is used here. So this is very important thing which you have to know. Understood? So concentrated sulfuric acid, why is it used? Because of its non-volatile nature. Non-volatile, in other words, you can also say the boiling point is very high. The boiling point is above 360. It's almost 360 degrees Celsius. So what happens? It does not go into vapor state. So this point is a very important point. Then the next point, we have seen when we take these things, the temperature is always kept below 200, isn't it? The reaction temperature we saw here, when we are writing the reaction, what did we write? Sodium chloride, they are reacting below 200 degrees Celsius. So why don't we go above 200? Clear? The reaction temperature is always kept below 200. So why it is kept below 200? We'll write down here now. So write down the reaction temperature is always kept below 200 degrees Celsius because at higher temperature what will happen? Because at higher temperature sodium sulfide, not sulfide, sulfate, 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 that is Na2SO4 is formed. So if the temperature is high, it forms sodium sulfate. Clear? So sodium sulfate, then what is the problem here? This sodium sulfate, what happens? It sticks to the glass. It fuses with the glass. So whatever glass apparatus we are using, it will stick to that, and then that apparatus cannot be used again later on. Clear? And moreover, as it sticks to the glass means the container becomes thicker. Since we are heating, we need to heat it more. So the lot of energy will be wasted in heating the container only because of the formation of the crust. A crust is formed, and therefore that crust cannot be removed. Okay, so sodium sulfate is formed, which sticks, or you can say fuses, which sticks to the glass, forming a hard crust. It sticks to the glass, it forms a hard crust. Clear? Which is difficult to remove. That means once it is used, we cannot reuse it. Clear? So the apparatus becomes unusable, useless, in other words, isn't it? And the second thing is, whenever we are taking this, then in this case, what will happen? The apparatus is becoming useless, and the second thing is, a lot of energy is wasted when we are heating it, isn't it? We are heating the glass along with the crust, so to get heated, it will take more time, means we are wasting energy in that case. Clear? So the next thing, here the reaction I'll give you, NaCl is reacting with H2SO4, concentrated only. The temperature is above 200 degrees Celsius now. What will it form? Na2SO4 plus HCl. It's not that HCl is not formed. HCl is formed, isn't it? But there are other reasons why we are keeping it below 200. Yeah. So the apparatus becomes unusable, isn't it? Unfit for further use. And we have to heat it to a high temperature. So what we can write down? It makes the apparatus unfit for further use, and then due to the formation of the crust, a lot of energy is wasted during heating. A lot of energy is wasted during heating, and since we are heating to a higher temperature, it may lead to cracking of the apparatus. It may lead to cracking of the apparatus. So these are the things which you have to know. Understood? So why temperature is kept below? I've given you all the reasons here. Especially sodium sulfate is formed that fuses with the glass and forms a hard crust. That is the main thing, and due to that, all these consequences are coming in. Understood? So This was one of your points to note. Then the next point to note, these all things are asked in your small questions. 40 marks of your paper in the beginning are short questions and they are compulsory. These things are asked there. Okay. So the next point, drying agent, what we are using? Concentrated H2SO4 is used as a drying agent. Excuse me. Concentrated sulfuric acid is used as a drying agent. We don't use other things. Clear? Concentrated drying agent as it does not react with HCl gas. Clear? Both are acidic and therefore the reaction does not take place. But there are other drying agents also. This is not the only drying agent. There are other drying agents, but we don't use those things. Clear? So other drying agents. Other drying agents like CaO, calcium oxide, is a drying agent. P2O5, that is also a drying agent. Clear? This way there are many, etc. cannot be used. So these things we cannot use it. Clear? Why? As they react with HCl. And when they react with HCl, you won't get HCl, you'll get other compounds only, isn't it? So to form other compounds. Understood? So to form other compounds, which compounds are formed? We'll see here, but these reactions are not very important. Clear? Calcium oxide, if I had taken with HCl, it will form CaCl2 plus H2O. So you won't get hydrogen chloride. Instead of that, you'll get calcium chloride there. Isn't it? If I had used P2O5, then this will react with HCl. It will form POCl3, and along with this, you get HPO3. So other compounds are formed, isn't it? Equation has to be balanced. So always give a balanced equation. Try to give a balanced equation. This is also balanced. Understood? Unbalanced equations are wrong. So always try to give a balanced equation. Is it clear? These all points to note, you have to know. Clear? So these points, we have completed all the different aspects of preparation of hydrogen chloride. Clear? I'll just go to one more thing. If I show you the diagram again, the diagram of your preparation. You can see again the diagram there, isn't it? Here, just one more thing I'll tell you. Whenever we are using this, in this case, what will happen? When we are taking this, then in this case, you can see the thistle funnel is used, isn't it? the thistle funnel. This is your thistle funnel, this one here, and this thistle funnel, this is the end. You see the end. The end has to be dipped in. The lower end should be dipped in the acid itself. If that is not dipped in, then the gas can escape from there. So always remember this lower end of the thistle funnel should be dipped in the acid. Clear? And then same thing here also. This end, if I take, this end has to be dipped inside the thistle funnel. Not inside the thistle funnel. It should be dipped inside the liquid. Yeah, this thistle funnel, the lower end should be inside. Through this, we are adding sulfuric acid. It is going here, isn't it? And then this is your sodium chloride. Sodium chloride is a solid. Acid is a liquid. That's why we are adding the acid through the thistle funnel. The lower end of the lower tip of the thistle funnel should always be inside the acid, dipped inside the acid. Always remember that. Yeah. So this things we have completed the laboratory preparation part of hydrogen chloride gas. But you know, we don't only use hydrogen chloride, we use hydrochloric acid. Most of the time we use hydrochloric acid, isn't it? So how that is prepared, that also we have to see. But before that, I'll give you a few things about this hydrogen chloride, and then later on we'll go to hydrochloric acid. Yeah. So let's talk about the properties of this hydrogen chloride as a gas. Then later on we'll see as a acid, how does it behave. Yeah. Okay, look here. Properties of hydrogen chloride gas. Here we are not talking about the solution, we are talking about the gas. And when we talk about this, first we are talking about the physical characteristic. Clear? Physical characteristic, then we'll see the other things. So physical properties. What are the things which you have to know? Clear? If I talk about physical properties, it is a colorless gas. Hydrogen chloride is a colorless gas. And this colorless gas, what will be the taste? Actually, you should not taste it, but you should know the taste. What will it be? It's an acid. So sour taste. It will have a sour taste. It will have a pungent, irritating odor. If you smell it, you won't feel it good. It won't be a good smell. Yeah. You may get choked also. Yeah. Burning sensation in your nose will be produced. So irritating. Then the next thing is, what about the solubility? Just now we said solubility. Main thing is solubility and its density. Density we have already said. What will it be? Let's talk about this one by one. It is heavier than air. It is heavier than air, isn't it? Because the vapor density of this one was 18.25, isn't it? And that of air is 14.4. So if you compare it, it is 1.28 times heavier. These numbers you don't have to know. Clear? How many times heavier, that you don't have to know, but it is heavier, that you have to know. Understood? These are not very important. Then the other thing, it is highly soluble in water. This we wrote in the beginning only, isn't it? It is highly soluble in water. Clear? So when I take this, one of the consequences of this is, if you take hydrogen chloride in a container, if you just open the container and outside you have air, air contains moisture, so it starts giving out fumes. Clear? So it fumes in moist air. Fumes in it fumes in moist air. Why does it fume? Because HCl gas is combining with the moisture, it dissolves in that, and therefore you can see the fumes. Understood? So why does it fume? Because it is highly soluble in water. As soon as it comes in contact with water, it dissolves. Okay, and this high solubility of water, how can you prove it? Hydrogen chloride is highly soluble in water. How can you prove? There are experiments for this. Yeah. So we'll do this experiment to prove that HCl gas is highly soluble in water. Hydrogen chloride gas is highly soluble in water. How can you prove it? Clear? So to prove it, what we'll do? We'll carry out an experiment. Experiment to prove that HCl gas is highly soluble in water. We'll take an experiment. That experiment has a name also. It is called fountain experiment. This experiment is called fountain experiment. So fountain experiment, how will you carry it out? Clear? For this again, you have a what is called a diagram. In this diagram, generally what will happen? You have a container. So I'll give you the diagram here only. You have a round bottom flask, you know, round bottom flask will be like this. This diagram again, you have to learn it. You have a flask fitted with a stand. It's upside down, you can see. So this, we are fixing it on a stand. Clear? This will be fixed on a stand. And when I take this stand, here, I'll take the cork or rubber and make it airtight. Clear? In this, I'll pass two things. One is your thin tube, and this thin tube has a small opening that is called jet opening, or you can also call it nozzle. Nozzle or Z opening, Z opening. Clear? The opening is very small. Then this end, we dip this in a solution. Clear? This we can take water also, but instead of water, we take blue litmus solution so that we can prove other things also. Here we are taking blue litmus solution. So blue litmus solution. Then here we'll put one more thing. We'll put a dropper. You have seen a dropper has a rubber end at this one. So this dropper, it is filled with water. This dropper is filled with water. This is simply a beaker, and this is a stand on which everything is kept. This end is your nozzle, isn't it? I told you, you can also call it jet tube because the opening is very small. So this is your diagram. You have to draw this diagram. And then what we do now, look here, this container, is filled with HCl gas. Hydrogen chloride gas is filled here. Now, hydrogen chloride gas is here, the water is here in the dropper. They are not in contact because the dropper, inside the dropper you have water and outside here you have HCl. So what happens? We'll just press this dropper. As we press this dropper, what will happen? HCl gas starts coming out from here. So when not HCl gas, water starts coming out from here. So water comes out means it immediately comes in contact with HCl. So what will happen? This HCl starts dissolving in it. HCl starts dissolving. So once it dissolves, this place, the gas is being dissolved means creates a vacuum. And to fill up that vacuum, what will happen? The liquid from here starts moving up. So this blue litmus solution, you'll see this tube filled with blue litmus solution. It will come here. Since this is a nozzle, a Z opening, what will happen? You'll see a fountain coming out from here. A fountain is formed. But that fountain will be red fountain. We are using a blue. This whole thing will be blue. Till here it will be blue. But when the fountain is formed, it will form a red fountain. Clear? So this red fountain, why is red fountain formed? Why is a red fountain formed? Because red fountain is formed because of acidic nature of hydrogen chloride. Clear? So I'll just show you the diagram here. You just see the thing. Your diagram is like this. So you can draw this diagram. Okay, all of you have copied. Any problem here?
No, sir.
So look here, what I told you, you can see there, what will happen, blue litmus solution, slowly it moves up. And then what will happen there is, when you take this is blue litmus, isn't it? This will move up. So when it is moving up, when it comes out from here, then what will happen? This portion will be red in color. Clear? So what happens? HCl gas is acidic in nature, that you can know about it. Clear? So this shows two different things. One, it is showing extremely high soluble because since we are pressing this dropper, water comes out, isn't it? This dropper, we are pressing it out, water comes out here, that water dissolves HCl, creating a vacuum in this flask. And that vacuum is created means to fill up that, due to atmospheric pressure, this will move up and then we see a red fountain. Clear? So red fountain is formed. That red fountain, the blue turns red. That means it is showing the acidic nature of HCl gas. Clear? So this part you have to know it. Understood? So fountain experiment is a very important experiment. You have to learn it. Okay. So today we'll do this much only. All these things, whatever I've given you, all these things are very, very important. You go through it, learn it. Okay. All the points which I've given, they are very important. Learn it. To next day, we'll see the other part. Okay. So learn all these things and be ready next day. Yeah.